Hi students, the topic today what we are going to see is static characteristics of instruments and dynamic characteristics of instrument. The previous class already we had a discussion on static characteristics. Two static characteristics we have discussed in the previous class itself, and only the 4 to 5 topic of static characteristics were not discussed. So the another static characteristics what we are going to see is repeatability. What is repeatability? So you all know repeatability in the sense which is nothing but repeatedly what we are going to do. So whatever the reading you are going to do, repeatable. For example, for a particular instrument, I am just going to calculate the measurement value repeatedly when the same input is applied for a short period of time. That is what repeatability called. But the same instrument, the observer, same instrument with the same observer, same location. That is what the constraints while you are doing the repeatability. So it's an ability of measuring the instrument to give same value every time. The measurement of a given quantity is repeated. But while you are repeating the value, you should get a correct thing. If the value is changing, then your repeatability is not okay. Then next static characteristics is about reproducibility. Reproducibility in the sense while the observer calculating the value for measuring the instrument, it should reproduce the same value. For example, if you are taking the value today, tomorrow also you are doing, and 2 days after also you are doing. But whenever you are going to do, the reproducible of the value should be same. That is what reproducibility. The next one is called the drift. Drift in the sense it is nothing but it is an undesired gradual departure of the instrument over a period of time. That is the drift, which is nothing but whatever the gradual shift from the zero position or some other period. It will take some initial time duration. After that, whatever your instrument is going to give a shift, that is what an indication of the drift value. And the drift, which is nothing but it is because of environmental parameter, or else if the instrument is falling with some fault, then this problem may occur. So while you are concentrating on the drift, there are three things. The first graph you can just look at. The first one is an example of zero drift. The second one is an example of sensitivity drift. And the third graph, it's a combination of both zero drift as well as sensitivity drift. Zero drift in the sense there is a shifting from the zeroth position. So that is zero drift. Sensitivity means it is proportionally taken, but there is a few shift. If both are combined, that was the third graph shows. So while you are looking here, the zero shift is nothing but the whole calibration is shifted by the same amount. It is due to slippage or due to warming up tube circuits. That is nothing but while you are starting the instrument, if you are not doing a zero shift or span, that is whatever the instrument you are going to start, while you are going for the measurement point of view, there is a two knobs way there. One knob is for zero adjustment, the another knob is for span adjustment. Whenever you are going to start the experiment, we used to start with the supply, but we are not supposed to do that. We have to bring the switch into the zero position, then only you have to start. So if you are doing a proper arrangement, the zero drift can be avoided. Even the span drift also can avoid it. So span drift is also called it as a sensitivity drift. So that sensitivity drift is if there is a proportional change in the indication of all along the upward scale, then it is called sensitivity. So the sensitivity drift and the zero drift can be avoided by proper calibration. The next one is about the dynamic characteristics. So you all know dynamic characteristics means what? Dynamic characteristics, which is nothing but the instrument should vary with time factor. Then it is called as a dynamic characteristics. So the first dynamic characteristics is what? Speed of response. What is speed of response? Speed of response, which is nothing but if the instrument is responding to a change in value, the quantity is varying. It is only because of the speed nature. For a particular speed of time, my instrument is going to change. The response is going to vary. Then it is called as a speed of response. The second one is called fidelity. Fidelity in the sense it is nothing but the ability of measuring instrument to reproduce the output in the same form as it like an input. That is nothing but whatever the change you have done, the input is sine wave and the output is also sine. Then that is called as an fidelity. So it should reproduce the output in the same form as an input. If it is not so, then there will be an error. Next one is about dynamic error. Dynamic error, which is nothing but the difference between the indicated quantity and the true value of the time varying quantity. So before getting into the instrument, you should calculate the value of measured as well as true value. So after getting the true value and the measured value, you have to calculate the error. That is what called dynamic error. The next one is about overshoot. So overshoot, which is nothing but whatever the instrument you are going to use. The instrument itself, it consisting of some dynamic characteristics, that is because of inertia, or it is because of the weight, or it is because of the moving part. The moving part is what? The pointer of the instrument. So if these things are not in a correct position, then there will be an error. That is what called as an overshoot. The overshoot is defined as a maximum amount by which the pointer moves beyond the steady state. That is nothing but the overshoot means it is not settling properly. The oscillation is going to happen. Then that is called as an overshoot. This is what the another dynamic characteristics. The next one is called as an error. So while you are talking on error, there are different types of errors we have. What is the meaning of error? The error, which is nothing but the difference between the true value of the size being measured and the value found by the measurement. So how you can calculate the error? Because you all know from the standard you can calculate the value and you are measuring the value. So you have two values. One is your measured thing, the another one is your true value. So while you are taking the difference between those two, you can able to calculate the value of error. If you want to calculate the percentage of error, then what you are supposed to do? Whatever the value you have calculated, that should be multiplied with your 100. That is what percentage of error. So this is how the error of a particular instrument can be calculated. There are so many different types of error while you are calculating the measurement. That is what the next topic we are going to see. What are all the error and how the errors are coming? What are all the possibilities of error and how you can overcome the error? That is what our next topic we are going to discuss. Okay. So what was the conclusion for this particular thing? Static characteristics, dynamic characteristics, and the static characteristics, what are all the discussion we had? Dynamic characteristics, what are all the discussion we had? So you have to, while you are studying, you have to compare both two and you have to come into the conclusion. This is what the main characteristics of an instrument for your measurement system. Thank you.